Motorcycle e-call, as you probably realized in the video, that's a topic that is discussed quite frequently in the Brussels administration, and it's also discussed amongst ourselves in the industry. We do see the opportunities, of course, and they are obvious. Reduce rescue time, save lives, and reduce the consequences of bad injuries. Sometimes we scratch our head a little bit if we talk about opportunities and impacts, because if you talk to accident researchers who stick their nose into accident data, you get all sorts of answers on impacts between 1% efficiency to 15% efficiency. But that's not our topic for today. Our topic for today is more the challenges. Now, you might say, hey, wait a minute, what challenges, you know? E-call is introduced in cars in 2 years' time. The infrastructure is there. The e-call boxes are ready for cars. So all you need to do, squeeze it down, make it smaller, put it under the seat of a motorcycle. What's the problem? Now, you probably imagine what my next sentence will be. Yeah, surprise. A motorcycle is not a car. We have completely different vehicle dynamics, and we have completely different, more sophisticated accident scenarios. And as you've seen this morning in the presentation of Virginia Tech, the accident scenarios are quite different from cars. So we're actually starting, if you like, with a clean sheet of paper. But now, before we go into details, I know you're all familiar with how e-call works, but let's still have a look at how does e-call work. And I hope this works now. It does. So you have an accident, car in this case. You have the position via the GPS system. Now the car has realized, God damn it, I had an accident, so I need to send an e-call. Now the car does that. A minimum set of data plus possibility for voice connection goes to the network. The network routes it on to a PSAP, great word, public service answering point. This person decides whether he needs to call back and say, are you injured? Is any problem? Shall I send the emergency? Now, in case this person doesn't answer or says, yeah, it's a serious accident, he will inform the rescue service and at the same time give out a traffic information warning. The rescue service goes to the place, picks up the person, brings him to a hospital. Now that is a basically simple thing. Question for us is, what happens if we replace the car with a motorcycle? Now let's do so. So, same scenario. We have a motorcycle crashing. GPS information is available in case the motorcycle has a GPS system or an e-call box. Now, the call goes to the PSAP. Now, we see a little difference here already in red. The voice connection is a question mark. I'm not going into details right now, but just imagine, I mean, motorcycle doesn't have a loudspeaker system, doesn't have a microphone, and a motorcycle is not a closed cage like a car. So there are some questions to be answered if we come to voice connection. If we don't have a voice connection, this guy cannot ask, are you injured or not? That means our triggering got to be pretty accurate. Otherwise, you get a lot of false calls. Now, that's the little difference. You can say that's a little difference. The rest is pretty much the same. Traffic information, send rescue service out, and the guy is taken to hospital. Now, triggering. Let's now call triggering and motorcycle the front end. On the front end, we have the triggering question. How do we trigger an e-call? Now, front end. Let's now have a look at the front end and see what are the differences on the front end between car and motorcycle, because the back end, as you can see, except the voice connection, is pretty much the same. I mean, there's no need to discuss it in depth. All right, what's the difference? What's common? Well, the rescue chain is common. Requirements for power supply. I mean, an e-call must work if the vehicle is destroyed. So that means we have to have a safe power supply, which for pneumatic devices, by the way, is not guaranteed. We are talking about a safe supply in the vehicle, which is very important to us. And then infrastructure, as I said, and maybe a future business case is pretty much the same. Now the differences are obviously, surprise, surprise to many of you, motorcycle and rider separate. It's quite different to car. And consequently, the forces that are applied to the motorcycle and the rider after the crash could be entirely different. And also, another problem we see is the vehicle location of the motorcycle and the rider may be different. In the best case, it's just a few meters, but in the worst case, it could be, down on the side of a road in the Alps in a place which is hundreds of meters away. And then, again, referring back to this morning's presentation of Virginia Tech, the accident scenarios we have are unfortunately very, very complex. We have different stability criteria. We need different sensor types to sense these sort of accidents. And we need a omnidirectional sensing. I mean, a motorcycle in a way is a little bit like an aircraft. We work in 3 dimensions. We bank, we go up and down, we have pitch, left and right. Forgive me, guys in the car industry, but the motorcycle stability criteria is a bit more complex than that of a car. And so is the accident recognition if we talk about e-call. And then let me touch the voice connection briefly. I said already, a car has a cage and a microphone and so on, so you can talk there. We all know this every day when we drive in the car and we do our telephone calls. On a motorcycle, we don't have any of this. And apart from that, since we are in the open, there's ambient noise, there is disturbance, etc., etc. And there is a distance rider-vehicle. In the worst case, the rider is far away. How shall that work? These are all open questions. We don't have a solution yet. If we would have, I wouldn't be standing here. I could sit in a beer garden and say, well, we've all done it, but we haven't. There are a lot of significant questions still open. Now, the next critical point, which I already mentioned, is triggering. Let's have a look at the triggering topic. And actually, from industry point of view, triggering is our main challenge. And again, if we compare car and motorcycle, what we have to acknowledge is that the e-call triggering in a car is based on activation of airbags. Now, the car industry has years and years and years of experience in triggering airbags. They have best practices, there are some certain standards. It's known. We don't have airbags, with the exception of a few motorcycles in the past where we experimented with them, but we don't. And again, as I said in the beginning, our accident scenarios differ quite from car accident scenarios. So in our technical definition, we have to ask ourselves the question, what sort of accident scenarios do we actually take as a base to define when an e-call should be triggered and when not? We don't have this simple accident scenarios like on cars. Now, you can easily imagine, if we look at motorcycle now, we can say that there is no best practice and our triggering is not defined yet. I already said the accident scenarios are complex, and rider and motorcycle separates after crash, and we have to put a question mark on what injuries does the rider have, and is it worthwhile to make an e-call or not. So there are substantial unsolved issues at this point in time, and we need to focus as a first step on what are our minimum requirements to make an e-call work, to have a reliable, properly designed system that triggers an e-call. Now let's have another topic considered, not a technical topic. There is another issue that makes us sometimes a little bit nervous. That's the topic of liability. Now, as you know, we produce motorcycles. We don't produce IT systems. So if we are to establish an e-call system, we need to consider the vehicle first, because that's where our competency is. And that's where we are liable for. We are liable for our motorcycles. We cannot be liable for other systems that are out of our control. So our first step is to say an e-call system must be on the vehicle, on the motorcycle. And the systems that are not in the vehicle are not in our control. That means that cannot be part of our minimum requirement thinking at this moment. Now, how to get out of this vicious circle, if you like? Certainly, we need to do more research to define, A, the limitations of such a system, and that it's 100% sure there will be limitations. And the second thing is, what are really the minimum requirements? And for us, minimum requirements are very important in a respect that, and let me now quote, also being European, let me quote an American philosopher, John Waldo Emerson. Simplify, simplify, simplify. Then things work. So we want to simplify as much as we can and say, these are minimum requirements and we can make sure that it will work at the end of the day. But that requires still a lot of research to be done. So, what is our strategy? As I already said, we need to define a PDW e-call system and its requirements. We have already submitted a research proposal some time ago to the Commission where we wanted to define these minimum standards, and we had a proposal how to do it in detail. Secondly, we are planning to participate to a Horizon 2020 project regarding motorcycle safety, where e-call is a part of it, a part of the research project. So we are active and we are taking up the challenges. Now let's look at general requirements. Some of what I show here maybe I've already said, but we have to make sure that the users understand what the system can do and what not. And that was something that was also discussed yesterday with other topics. We have to make sure that our customers know how much they can rely on the system, what it can do, and most importantly, what it cannot do. Because this is not a 100% life insurance, for sure not. We have to supply a simple but robust system that works in every critical condition. I'm not going into details, but you can imagine things like crash resistance, power supply, and. And therefore, our idea from industry side is we want to establish a sort of standard or industry requirement amongst our members in order to make sure that customers would understand if it's according to our standard, it will work.